Statement of well ordering principle. Well ordering principle. Well ordering principle. This is an important principle which required to prove Archimedean property and mathematical induction theorem. So statement of this well ordering principle is that every non-empty set, every non-empty set, every non-empty set of yes of non-negative integers, non-negative integers, integers contains contains a list element, contains a list elements. In other words, there is some integer. In other words, there is some integer. There is some integer a belongs to yes, such that a less than equal to b for all b belongs to yes. So this is a well ordering principle. Now we will prove an Archimedean property. Archimedean property. Archimedean property. The statement of the Archimedean property is if A and B, A and B are any positive integers, positive integers, then then there exist there exist a positive integer, positive integer n such that a n is greater than equal to b. This is one to prove. We prove this property by using a contradiction. Proof is a very beautiful. Look at this. Let us consider the contradictions. That means if for some a and b a and b na is less than b for every positive integer. We are taking contradiction. So every positive integer n, that is for any two integer a and b, or for some integer a and b, na is less than b for every positive integer n. Now let us construct one set. Suppose S is equal to, this is my set which consists of the element of the type b minus na. A, what is n? N is a positive integer. Positive integer. Look at this condition. This na is always less than b, so b minus na is positive, and therefore this set S must consist of entirely positive integers. So yes contains entirely positive integers. Entirely positive integers. Okay, why? Because NA is less than B for any value of any positive integer n, and if we take B minus NA, that will be positive integer, therefore S consists of entirely positive integer. Now if n consists of entire it is a set of positive integer, we can apply well ordering principle. That means if S is a set of non-negative integer, it must have a least element. So this set also must have least element. So that means this set S must have least element by well ordering principle. Least element. Why? Because of well ordering principle. We have applied here well ordering principle. Since S is a set of positive integer, and we can apply well ordering principle, and suppose that B minus MA is the least. Okay, so the least element of this set is a B minus MA, since all the element of this set are of the type B minus NA, then B minus MA is the least. Now look at this here, B minus M plus 1 into A. So what you think about this element? Again you can you observe that this is again of the type B minus NA, and here B minus M plus 1 into A is also element of yes, but B minus M plus 1 into A equal to B minus MA minus A, and it is B minus MA. This is an single number, and from this number we are subtracting A, therefore it is a smaller than B minus MA. If it is smaller than B minus MA and it is an element of S, it is a positive element of S, this is the contradiction, to the fact that B minus MA to that B minus MA is smallest. B minus MA is smallest smallest element of S, and therefore our assumption that this NA is less than B for every integer is an false assumption, and hence uh, there exists an integer n, positive integer n, such that NA is greater than B. So friend, thank you for watching.